example of a quadratic function with a horizontal translation. So we have our original function g of x, which equals the quantity of x minus 4 all squared. And we want to identify the parent function. Well, this is going to be a quadratic function. So it's going to be the shape of a U, a parabola. The parent function equation is y equals x squared. So in our table down here, this will be our y equals x squared. X and y. We'll substitute 0, 1, 2, negative 1, negative 2. All right. Now let's figure out what is the transformation or transformations that exist in our function. Notice that this minus 4 is inside the function, and there's a subtraction going on. So I'm going to go back to our previous set of notes. All right, when it is inside the function, there's a parenthesis going on, it's going to be a horizontal shift, so it's going to affect the x-axis. And right now it is a minus 4. So let's go back. So here's our equation. Come on. I think my smartboard just stopped on me. Yep, it did. So let's give it a minute here. It's frozen. All right, now it's coming back. All right. So x minus 4. So go ahead and take a minute and say, which direction is this function going to move? All right. So you should have come up with, when it's a minus 4, in your notes, it's going to shift h units to the right. So what you do is you add h to all the x coordinates. So we have to think opposite when it's inside the function, I tell my students. All right, so minus 4 is inside the function, so it's going to shift it right 4 units on the x-axis. Call this a horizontal translation. Right 4 units. In order for us to do that, imagine here's our original parent function, we're going to shift it right 4 units. So the rule is we're going to add 4 to all of the x values to shift every order pair to the right. Now we don't have any vertical translation, so our y is going to stay as it is. So in our chart, our x plus 4 will be changed, and then our y stays as it is. And this would give us the function x minus 4 all squared. All right, let's go ahead and graph that parent function again. So we're going to evaluate y equals x squared. We've done this before. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. Negative 1 times negative 1 is 1. Negative 2 times negative 2 is 4. All right, let's graph it over here. 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. All right, so there's our parent function again. You're going to be awesome at graphing the parent function for the quadratic in this lesson. Y equals x squared. Now we're going to go ahead and find the ordered pairs of our g of x function. So our rule says we have to take all of our x values and add 4. So we're going to start with this set of values and add 4. So 0 plus 4 gives us 4. 1 plus 4 gives us 5. 2 plus 4 gives us 6. Negative 1 plus 4 gives us 3. Negative 2 plus 4 gives us 2. All right, y's. None of the y values are going to change. So we're going to go ahead and just put them over here. 0, 1, 4, 1, 4. All right, we should see from the blue function to now our red function that all of the order pairs have moved right 4 units. So here's 4, 0. 5, 1, 6, 4, 3, 1, 2, 4. All right, this is our g of x function, now graphed out. All right, let's identify the domain and the range. The domain for all of our parent functions and all of our quadratics, when we do the translations, is going to be domain is all real numbers, negative infinity to positive infinity. All right, our range of values. I'm going to go ahead and create a horizontal line right here at y equals 0. Imagine everything above or on that yellow line exists for your range of values for your y values. So we say in this case, our range of values is y greater than or equal to 0.